Hi, welcome to Verdi training program. In this section, I will introduce how to use Verdi to find the root cause of a wrong value by using the Temporal Flow View. Now let's see what you can expect to learn from this video. Firstly, we will talk about how to use the active trace to find the active drivers from a transition. Then we will learn how to find the root cause of a bad value by using the Temporal Flow View. In the end, we can analyze the propagation paths with clock domains and trace from control pin. Assuming from the spec we know the correct transition here should be 3 to 4, but now we see 3 to AA here. Apparently it's a wrong value, and now let's see how we can use Verdi to find the root cause. Usually when we see a wrong value, the first thing comes to our mind is to see its active driver. In Verdi we can just double click the value change to execute active trace. Let's turn on the active annotation to see the value annotated on source code. Now from the source code we can see that the signal was assigned from ALU out, and we can continue double clicking the signal to trace the active driver. Now we have traced to a case statement. From the value annotated on source code, we know that the value AA comes from both signal A and signal B, so now let's trace signal A first, then come back to trace B later. Again, we can double click on signal A to trace the active driver. Now we have traced to an always block, which means we need to also consider the clock domains and another reset signal. Anyway, let's continue to trace by double clicking IXR. Now we have encountered another always block, which means we need to consider another clock domain again, and also another reset signal. Of course, we can continue to trace until finding the root cause, but it's difficult to remember what happens in every branch, and it's very easy to lose track for the complex propagation paths. Now let's use the Autotrace capability in Verdi and see if it can help us to find the root cause more easily. Let's go back to the 3 to AA transition in the waveform view, and then just click on this Autotrace icon. The Temporal Flow View is open and it has traced to a functional block. We can turn on this Show Source Automatically icon to see the corresponding source code. Now when we click this functional block, the corresponding source code will be bring up. It seems the block is a case statement which we just traced in the source code a while back. In this statement, all three inputs are valid drivers and contributed the AA value, so Verdi stops here. The same as our previous trace, let's start from signal A first. We can use the trace this value capability. The Temporal Flow View will try best to trace through multiple cycles until it finds the root cause. Now you can see the result is much different than tracing in the source code. Verdi traces through multiple cycles and propagates through many cells, and leads us to the root cause in the left-hand side. From this propagation path, we can see the wrong value happens in 800 nanosecond is actually caused by the value change on data out signal, which happens on 650 nanosecond. And from the input signal, we see a M, which means the input comes from a memory. We can double click the memory signal to see when it was written. In this case, we didn't dump the memory into FSDB, but Verdi can base on the memory read, write, address, and initial value to tell users when this value has been written. In this case, Verdi told us the memory value is assigned during the initialization. If you want, Verdi can also calculate the memory content for you. Now don't forget we have another signal need to be traced. Let's go back to the 800 nanosecond and trace the signal B. Again, we can select the signal and then invoke the trace this value. Now from the propagation path, we can know that the signal A and B both drive the wrong value in 800 nanosecond. But after tracing back through several clock cycles, it turns out that these two signals are actually came from the same driver in 700 nanosecond. Try to think about how difficult we can know this by tracing the source code step by step. But in Temporal Flow View, we can see how the propagation path has been unrolled by time axis and how the value propagated to drive the wrong value. and all these are done by just one command in Verdi. Besides the propagation paths, you may wondering why there are some special marks in the temporal flow view, and what does it mean? For example, we see an exclamation mark here, and it means the control signal also has value change in previous clock cycle. Verdi can recognize who is data in and who is control, and will automatically trace through data in. But what if the actual problem came from the control pin? Let's do some further analysis to see the detail of this register. We can use the right mouse button command to show the clock domain of this register in the waveform view. Now we can see the clock domain belongs to this register has been added to waveform view. Let's move the temporal flow view to another place to view it along with the waveform view. We can turn on this icon to add all signals to the waveform view automatically. Now let's click this register. All signals will be added to the waveform view. Now in the waveform view, you can see the yellow triangle, and it means the sampling time. In this register, clock 3 is the clock, and IDRD is the data input. You can see that IDRD has a value change in previous clock cycle, so that's why Verdi sync is a valid driver and continue to trace from it. However, at the same time, the IDR load, which is the control signal, also has a value change within the clock cycle, and that may be the actual root cause besides the data input. The purpose of the exclamation mark is to notify users this possibility, and if you suspect the issue is actually came from the control pin, you can select it and continue trace from here. From the symbol, you can also see that there is a red dot in the control signal IDR low, which means there is a value change in the same clock cycle. Here, Temporal Flow View shows enough information to let users to do judgment. Now we can start another trace from this control signal. Now let's see what we have learned from this video. Firstly, we use active trace to find active drivers by double-click the waveform or source code. And then we use the trace list value capability to find the root cause and unroll the path through multiple clock cycles in time axis. In the end, we can further analyze the path by recognizing the control signals and clock domains. This is the end of the video. Thank you for your time.